you asking about the southeast thing?
No.
Or something else?
No, I'm okay to do that.
Oh, it's graph, okay, right. Okay, I'm gonna look at 2 now. So, a mass of 2.5 kilograms is attached to the end of a string and is rotated around in a circle of radius 0.5. So you have this mass here, and it's 2.5 kilograms, and it's rotated around in a circle, and its speed is 4 meters per second, and the radius of the circle is 0.5 meters. Okay. And you know what? I'll open up the formula book too. Yeah? Question? No? Sure.
Is the first one the time?
T? Number 2?
Oh.
Huh? Yeah, that'll be a problem.
You get the opening up.
Yeah, no, hold on. I want to open up the formula book to show you where these formulas are in the formula book, okay? Where is physics books? This is on Moodle as well, this formula book. Okay. Now, you can see the formulas, constants, heat, there we go. Circular motion. There's all the formulas there. So, because it gives us the V, and because it gives us the R, I should work out what the omega is, because I might need it. Okay, so, first piece of business, the omega is V over R, which would be 8, when you calculate it. 4 over 0.5. Okay, so I have the V, the omega, and the R. That's great. What else is there? There's also acceleration and the time. Fine.
Why there is the acceleration? Because they just for no acceleration.
No. Because acceleration is the change of velocity, and velocity is direction and speed. So although the speed is not changing, the direction is. Okay. 3A. Alright, so firstly, they want the maximum tension in the string. So when do you think the tension would be maximum? At the top or at the bottom?
Bottom.
Be at the bottom, actually. Because think about it. If you swing this around slowly enough, it's possible that when it reaches the top, it could fall back down. So this means the string must be its least tense at the top. So anyways, the maximum tension is at the bottom. So let's draw the forces. So what forces act on this? There's only 2. Gravity. So can you type in 2.5 multiply 9.81 and tell me what you get, please? 24.5 newtons. And then there's an upward tension force T here. Okay? Which is bigger, the T or the gravity? No, the T, because if the gravity was bigger, it'd fall down. But because it's going up, the T is bigger. So the total force would be T minus 24.5. Does that make sense so far? Yeah. Now from Newton, what formula do you have for force? MA. So let's get rid of the F and replace it with MA. And do you know what the M is? What is it? 2.5. So you have this one. Okay? Is that okay so far? Yeah? You're not happy. What's wrong?
Just 1 step back.
Oh, I can't go 1 step back.
No, I mean explain.
Alright, okay. So it went like this. F equals this. First, is that okay? But from Newton, F is MA. But M is 2.5. Yep. Now, do we have a formula for the A when something is traveling in a circle? We do. If I go to the formula book, you can see A is V squared over R. Okay? So A, I'll write it here, A is V squared over R. So that would be 632, is it?
Yes.
Okay. And I'll just make a little note here. These ones I got from the formula book. But these ones here, I was given. Whoops. Okay. Now, Andy, do you mind doing 2.5 times 32? What do you get? 696?
8. Because I do all the things.
Oh, okay, give me 2.5 times 32, please.
8.
No, that can't be right.
8.
80.
Yeah.
I thought you said 8. Alright, 80. Oops. Go back to that. 80 equals t minus 24.5. So therefore t would be 104.5. And that's the maximum t. Yeah? What's wrong?
Because as you know, the centrifugal force
Yep.
is always to the center.
Yep.
So can we use the formula?
Which formula?
The F equal
M omega squared over R?
somewhere there.
Yeah. Yes, you can, yes.
That will just get you straight to the T.
No, because the force acting in the center is the T minus the gravity. It's the total force to the center, not whatever force is to the center. Now, if you look here, the B part is find the minimum tension, which will be where? At the top.
Yes.
Now, look very carefully. The key difference between the top and the bottom is this. At the top, we have a downward tension, which will be different now, it'll be smaller, but also we have a downward gravity of 24.5. So the total force, what would be the total force? What would it be? The total force. 24.5 plus T. No, slow down. Wait, I just want you to first realize that the only difference at the top is that the total force is T plus 24.5. That is the only difference. Whereas at the bottom, it's the T minus. So that means everything is exactly the same, except here, the sign gets changed here from a minus to a plus, which means this will become a plus, which means you would have T min would be 80 minus 24.5. And what's that? Not 120 something or whatever you said over there. What is it?
55.5.
55.5 newtons.
120.5.
Well, it's not. It's just 80 minus 24.5.
So just now what I said is F equal to M.
A. You have F equals M omega squared or is another formula, and F equals M V squared over R. But that F is the total F, not the T.
Can I put in, so the in front you use MA, so I can use this also.
Oh yeah.
It's the same thing.
Yep. I only did it this way because that's what's in the formula book. Oh, that's fine. That's fine. All right, and that's number 2.